Hi friends, welcome back. So here we are with another problem, or we can say a solution in AI. So here we have basically airline fare analysis. So we are going to do analysis on airline fares, right? So basically in this video we will particularly talking about the linear regression. So let's start with the deep study. So these are the variable columns that we have in our data source. So the very first option what we are doing is reading source file and checking data. So again we are importing pandas, numpy, matplot and seaborn, right? So this is the data set that we have. So I will also try to provide the data set. So this is the data set that we are getting. So here we are using an online link. So here we will get the airq402.dat, right, from this particular link. Now we are once reading this file, what we are doing is we are adding columns named as mentioned in the data file. So here what we get is file.column equals to, you can see city 1, city 2, then average flight fare, distance, everything you will get, because here you are getting only that file. So now we have assigned column to them. So next thing we will do data cleaning. So how will you do that? Getting total number of rows and column in the data frame. So first I'm printing the shape of data frame, that is the shape file.shape, right? So 999 is column rows and 11 are columns. Now total rows are file.shape, that is 0. Okay, file.shape of 0. So you will get the total number of rows because you are accessing only this index. And finally you are printing this total rows as well. So for data cleaning, what we will do is, first thing we will do checking the null column. So for that what we will do, we will get the function as is null.sum. So it will return all the total null values in the data set. So here you can see that everything is 0. That means there are no null values that are present. Secondly, what we will do is we will check the data type of each column to check if any type needs to be changed. So again, to check the data type, we will do file.dtypes, right? So it will return all the data type that we have. Okay, so here you can see that all the data types. Then we are checking the basic detail by using file.describe. So the describe function will again return all the all the values of count, mean, standard, minimum, interquartile ranges, right, and maximum function for all the columns. And finally you can see that mean of distance, average weekly passenger, market share is above median, right? So you can see that it is asking mean of what? Mean of distance. Okay, so mean of distance is above median. So here you can see that mean is above median, right? Then average weekly salary. So average weekly salary, you can see that that is also above median. And finally market share, right? So market share is also above the median values. Now let's do some EDA, exploratory data analysis. So first we will checking the univariate analysis. So how will you do that? First we are plotting our data that we have, figure of this size, subplot of 131, title is average flight fare, and SNS.displot. So average flight fare and green, right? So you can see that this is the average flight fare that we have. Secondly, what we are doing is we are getting the title distance. So here you can see this plot is for distance. Third, we are doing average weekly salary 33. So 1 of 3 average weekly salary. Secondly, what we are doing is we are again getting the average flight fare, right? So on the 131 plot. So 131 plot, average flight fare. So this is a box plot. So shall we check that whether this is a box plot or not? Average flight fare area, box plot. Next thing we have is the distance in the box plot, right? And next thing we have is the average weekly salary in the box plot. So here you will get all these value. Now from these values that we have, you can see that most of the flight fare lie between 100 to 300 with some outliers. So what it is asking about flight fare. So let's see, this is the flight fare, right? Average flight fare, and this is the average flight fare. So it is asking that most of the flight fare between lies between 100, okay, to 300. So this is our 300, right? With some outlier also. So you can also check that from 100 to 300 with some outliers. Yeah, most of them. Average distance ranges between 5 to 25,000, 500 to 2500, right? So average distance ranges between 500 to here you can see 2500, right? So if we check here again, so yeah, you can see that. Now next thing is, finally, most of the time average weekly passenger number is less than 200, but there are larger number of outliers. So most of the time the number is 200, but there are some larger number of outlier, you can see, that are even more than 8,000, right? So next thing what we will do is, again we will get the values for market share MLA, right? Average MLA fare, right? Market share LPA, average LPA fare, then market share MLA, then average MLA fare, and market share LPA and average LPA, right? So if you see that the market share MLA, average MLA fare, right, and the corresponding box plot as well, market share MLA, average share MLA, and average MLA fare, market share LPA, market share LPA, average LPA fare, average LPA fare. So these are the box plot with respect to them, right? Here you can see the outlier with average MLA fare and the outlier with average LPA fare. So what is it asking, what it is telling, average fare of both market leader and low price airline ranges from 100 to 300 with some outliers, right? So average fare of both market and market leader and the low price airline range, right? Market leader and low price, right? So market layer and the low price average, right? So next thing, market leader has 40 to 80% market share on most outliers, right? So it is asking that for most outlier 40 to 80%, right? So if we check here, 40 to 80%, right, with the market share MLA, and lower price airline has less than 40% market share on most of the outers. So for lower price airlines, right, the less than 40% market share on most of the outliers, right? So less than 40%, here you can see that, yeah, this is what the average LPF here. Now we are having a figure and axis of that, then width is also defining. Now we are telling, okay, that is the length of market leading airlines. Okay, so next thing, we are having the fig dot set size in inches, right? Then Seaborn for market leading airlines or MLA. Now we are having a loop of P in EX dot patches, right? So what it will do is it will annote all the string, right, by rounding them. So it will all the height, right, of length. Actually we are getting the values in percentage for all the box respectively. Okay, so here you can see that this way we will get the percentage on those height, right? Then HA, that is on center, V vertical, that is also on center, XY text 0 10 text coordination offset point. So here you can see that this will this way you will get the percentage at the top of each boxes. So FLDL, WN, UA, basically we are annoting all the strings, right, by their respective columns abbreviation. Now what it is telling that WEBN followed by DL happen to be market leader airline on most of the routers, is it? So you can see that this is our WN, and for DL you can see that this one. So WBN followed by DL happen to be market leader in the airlines of most of the outers. So because in WN we have 25.73%. Now figure again what we are doing is we are again trying to plotting for low price airline LP, right? So for low price airline you can see that the WBN, and if we check for lowest one, so WBN followed by the DL again happens to be low price airline on most outlier. Remember that this is the WBN followed by DL happen to be market leader airline on most of the routes, but also on the low price airline on most routes. Now bivariate analysis. So what we will do is here to do that bivariate analysis, we are again having random of random state 0, then data frame rs dot random 10 to 10, correlation also file dot correlation core dot style dot background gradient. So this is C map of cool warm, right? So this is the matrix or the data frame that we have. Average flight fare is most correlated to fare of market leader and low performing flight. So here you can see that figure is equal to this one, subplot also box plot market leading airline MLA average flight fare, we also have that, then SNS box plot. So you can see that low price airline LPA and average flight fare equals to this. So if you plot all the subplots, so here you can see that all the box plot for the market leading airlines and low price airlines, right? So here from these you can get that most flight have comparable median flight fare with some having very low values, all right, and flight fare of market leading airline and low price airlines seem to fall in similar ranges. So this way you will get the observation from that. Next, we will do multivariate regression and scatter plot. So again, for scatter plot, we directly call the sns.peer plot file that we are giving the data frame. Y variable will contain average flight fare and X variable will contain distance, average weekly passenger, market share MLA, average MLA fare, market share LPA, and average LPA share. So here you can see that for every x-axis and y-axis you will get the respective value, and you can see the scatter plot like how it is distributed. Even for average MLA fare you can compare this with market share MLA, or we can say average MLA fare with average LPA fare. So here you can see that how these are plotted. Now average flight fare is most correlated, right? Average flight fare, so this one is most correlated to fare of market leader, and low performing flight with mild correlation with the distance as well. Okay, and variables need to be scaled before further analysis. So yeah, they needs to be scaled further. Transformation seems unnecessary as most data point don't show any clear trend with average flight fare. So right, so for transforming unnecessary as most data point don't show any clear trend with average flight fare. Okay, still checking effect of log transformation on the data set, so you can check that. Now log transformation of independent variable, you are getting the log values for distance, average weekly passenger, market share MLA, average MLA share, market share LPA, average LPA fare, right? So D1 to D6 you will get that. Now what we will get is we will get the flight fare versus log distance. So this is the title, flight fare versus log distance and flight fare for X label, Y label, we have defined that. So you can see that both the plot for distance versus average weekly salary. So here you can see this is the log distance and this is the log of average weekly salary. So here you can see that how the relation between them looks like, or how the relation is scattered between them. Now given transformation doesn't seem to be adding much value going forth with raw data only. So here you can see that doesn't seem to be adding much value. So let's do further analysis, that is multilinear regression model. So here what we will do is dropping cities and flight name column as these are known actionable. So yeah, as we don't need cities and flight name, so we are dropping city from both the city 1, city 2. Then market leading airline MLA and low price airline for multilinear regression model. Next, we will split data into training and test again. So again, we will import a train test split from sklearn, right? Then np.random seed for 0. Now file train, file test. So we will get train test split, okay, on 70% of train sites and 30% of test sites. So the random state we are having 100. Now rescaling the feature. So again, to get that rescaling, we will import min max scaler, right? So from min max scaler we will able to rescale the features. So we will have this function that min max scaler into a scalar variable. Now apply scalar to all the columns except the dummy variable. Okay, so first variable will contain all the column that we need, and file of variables we will try to scalar dot fit transform in all these variables, right? So this way you will able to get the newly structured frame. So once you will call file dot head, you will get all these respective column. And also after describing this, you will get the further information about mean, whether it is greater than with our median or not. For you can see that average flight fare respectively for this one distance, then for average weekly salary, right, and so on so forth for average LPA fare and for median values as well. If we try to train the model, so we are having y train equals to file dot train POP. So here you will get the average flight fare of this train POP function. And finally, if we calculate the VIF for the new model, so for that you are importing variance inflation factor, that is VIF itself. So VIF will have PD dot data frame on this variable, x is also x new. Now we are defining VIF of features, VIF of VIF, rounding the values, and finally VIF of short values on the basis of VIF in descending order. So if you see that in the descending order, average MLA fare is 11.73, market share 8.13, distance 5.97, market share LPA 3.32, and finally the lowest one is average weekly passenger, that is 1.65. So that means the market share has a high p value and a high VIF. So what we will do now is we will drop the market share MLA, right? So then you will get the x new head like this. All right, now next thing we are again using the sm dot add constant of x new, right, and also providing the OLS model again for y train and x train LM and fitting them. If you again get the summary, so this time you will get that the value that is for r square, that is for AP statistics, or we can say AIC BIC will be changed in a slight bit. And next thing, if you calculate the VIF for the new model that we just created, so here you can see the same thing again importing VIF, variance inflation factor, right? So this will have the feature VIF VF again. Okay, so features and VIF will be these values. Now finally the market share LPA has a highest value, so again we will drop the market share LPA, right, of the value that is highest value. So next time if you again generate the OLS model and then the summary, you will see that the value of r square, like here is 0.964, but here you will see that again here 0.964, right, but the F statistics here is 4707, and here you can see that there is slight difference between 6261. Similarly with the all these metrics as well. Now next thing, again calculating the VIF for new model, right? So again one more time we are doing the same thing again. So here you can see that the feature VIF in the descending order. So average MLA fare 5.95 this time, average weekly passenger 1.51. So if this for distance also it is 5.40. right? So the average MLA fare is the single most important feature in that, right? So that is the average MLA fare. Okay, now distance and average weekly passengers are important to some extent, but not always, right? So here this one is the having highest priority. Next thing we are doing is residual analysis. So for Y train price, that is LR4 dot predict on X train LM, right? Plot the histogram of the error terms. So if you get the error terms, so here you can see that these are the error that will get from the Y train price, or we can say the Y train minus Y train price. So here you can see that it is normally distributed, or we can say error terms are normally distributed. Hence the prediction can be made because we are getting the normally distribution. Now making the prediction using final model. So what we will do is again defining all the columns, right? File dot test of num variable equals to scalar dot transform function, right? In which we are passing the file test of num variables, or we can say num variables of file test, right? And then finally we are getting the x test and y test. So for y test we are getting the file test dot pop of average flight fare and x test of file test, right? Then adding the constant variable to test data frame. Okay, you can see that how we can add constant into text data frame. And then at last what we are doing is we are dropping the market share MLA again, market share LPA and market LPA fare of their column as well. And finally we will have the predict of that newly model. So y prediction M4 will be the final variable for that. Now plotting y test and y prediction to understand the spread. So you can see that this is our y prediction, this is our y test of getting the PLT dot figure scatter of y test and y prediction M4 of figure of subtitle. We are providing subtitle, x label, y label. So you can see that this way we will get the distribution. And finally at the last we will get the variance score by importing matrix and matrix dot explained variance score of the y test and finally y prediction M4, that is this one, right? So finally you will get the 90% of the accuracy in that case. So here by this particular values we can assume that model is able to explain 90% plus of variance in test data and 96% plus variance in train data, right? So you can assume that. And finally what we can get is other model that can be applied here is polynomial regression to capture non-linearity in data. Yeah, decision tree with regression at nodes, right? And other way to of improving data is what? First is better independent variable that can be derived some independent variable including all the column that mentioning here, and completely new dependent variable can be introduced like number of flight playing on each route, right? So that can also be handy. And PCA can identify better independent variable with the minimum correlation. So if we talk about the final conclusion regarding this airline fare analysis, so you can see that I have noted everything. First is, as for multivariate analysis, average MLA fare is the most important independent variable, right? For multivariate analysis. So for multivariate analysis, average MLA fare, right? You can check that as well if you haven't noted that down. So you can pause the video, go back and check the multivariate analysis. Now the distance and average weekly passenger count also affect flight charges. Obviously that is also the big factor with the distance and average weekly passengers, right, of their count. Third is multivariate analysis gives decent model with more than 90% R2 on test data set. This we have already seen. Accuracy or read R2 can be improved further using feature explained above and using altered model or adding more variables. Okay. Fifth is transformation like log can improve model accuracy slightly, but still effect of average MLA stays most significant. And finally, understanding from EDA, most of the flight fare lie between 100 to 300 with some outliers. Secondly, average distance ranges between 500 to 2500, right? Third is most of the time average weekly passenger number is less than 2000, but there are larger number of outliers. Okay. Fourth is average fare of both market leader and low price airline ranges from 100 to 300 with some outliers. Fifth is market leader has 40 to 80% market share on most routes. Sixth is lower price airline has less than 40% market share on most of the out routes. And seven is most flight have comparable median flight fare with some having very low values. Eighth is flight fare of market leading airline and low price airline to fall in similar range. Okay, so this way you will get the final conclusion for that. So yeah guys, this was all about the airline fare analysis. We will also come up with some other analysis topics. All right, so yeah, thank you.